It's my pleasure to introduce Mr. Vikas, founder of Windsmit Air. He leads an emerging group dedicated to enhancing indoor air quality and ensuring optimal ventilation with new filtration methods. Windsmith Air focuses on regulating climate conditions within various structures ranging from residential buildings to hospitals and malls. Mr. Vikas is deeply committed to revolutionizing India's infrastructure by championing greener, intelligent, and smarter buildings, offering comprehensive building automation controls geared towards energy efficiency. Prior to this, he gained expertise at Johnson's Control with over a decade of experience. Today, Mr. Vikas will briefly overview us about IoT in HVAC for indoor air quality and energy optimization. Please join me in welcoming Mr. Vikas.
So my topic is IoT in HVAC for indoor air quality and energy optimization. You might have seen everywhere whenever you step up the doorsteps of any commercial spaces or the malls, the doors are being opening, and when you step up ahead, the lightings are taking you to the center stage. Again, when you move around and get into the corner, the comfort level of the air conditioning will optimize by the indoor temperature. Yes, that is totally the magic of IoT. And this IoT has now been incorporated in our HVAC industry to optimize the indoor air quality and energy efficiency. So I would relate this IoT to the technical leader. Why? I will definitely get into the details ahead. So in the next slide, I will discuss the set of topics, how the architecture of IoT is, importance of indoor air quality, that is more important after the pandemic has happened, and that is the more phrase phenomenon where every company is getting into the details. After that, we would like to discuss the challenges in the traditional HVAC systems. Once we get into the disadvantage, to know the disadvantage of the existing HVAC system will definitely help to understand the better IoT in HVAC. Then we'll see the benefits of IoT in HVAC, a short case study followed by I'll summarize the entire presentation in short recap. Now let's see the architecture of IoT. Just focus on the right side of my screen in the green color background where you will see the bidirectional data transfer. The upper side is the sensor which is dedicated to the field devices, and the lower side is the user. The data will transfer from the field devices to the user. Like in the building, the number of HVAC systems are being comprising like chillers, air handling units, VFDs. You can see in the bottom of the line, the building equipment with IoT sensors. That IoT sensor senses and passes the entire data to the advanced IoT controllers, which will take the decision and again forward to the upper level, which will secure in the detailed IT networks through routing. It will pass it on to the cloud, and cloud will pass into the particular user, whether it is from the smartphone user or the desktop user. Again, the data will be flow vice versa. Like I have already said in the right corner, if we have to command a particular air handling unit to the 24 degrees Celsius, this 24 degrees Celsius command will energize the wall. The data will pass from cloud to the security network, again to the downline advanced IoT controller, and this advanced IoT controller will take the decision on the basis of algorithm and open the wall. This is the simplest form of the architecture I could show to you. Now see the importance of indoor air quality. I have summarized three different problems which have been arises from the impure quality of the air. The common problem, respiratory health issues. Second one is the productivity and cognition function. The third one is more often in the commercial spaces, that is sick building syndrome. The respiratory health issues may be caused just because of the dust, molds, pet dander, and VOCs. The high levels of the pollutants and the impaired concentration reduces the productivity and the negative impact on the human health that affects the human decision making power. that is just tremendous and very harmful. Like I said, the common problem, the sick building syndrome, you will see whenever I think you might have experienced that issue whenever you enter to the common spaces where there is no ventilation, the closed area, and the number of occupancy is increased. You will feel the eye irritation, fatigues, and the respiratory issues. The building is already sick by these kind of parameters, and hence we can relate the building to the sick building syndrome. The common pollutants which are totally responsible for this common problems in the pure indoor air quality. The first is particulate matter, that is just arises just because of the smoking or any kind of combustion in-house or outdoor. Now, volatile organic compounds, VOCs, that is just because of the indoor paints, the chemicals inside the furnish, and so on. Molds and mildews will be arises due to the relative humid areas, and like in the ventilation duct, you can see these molds. Carbon monoxide, that is just again inefficient results of the inefficient combustion of the engines and the fossil fuels. Formaldehyde, that is just because of the glues and the compressed wood material inside the house. Now we'll see the challenges in traditional HVAC systems. Once we understand this traditional HVAC system, it will be easier to understand how the power of IoT and how we can use it into the HVAC system. The first is limited sensing and the control. The limited sensing and control comprises uh, the, uh, the irregular temperature sensing. And if you if you command to the particular air handling unit and adapt to the certain parameters and certain condition, the HU will not be optimize the current data, and it will just set to the temperature 24 degrees Celsius. I can definitely relate one Bollywood movie dialogue here from the मुन्ना भाई MBBS. भाई ने बोला 24 डिग्री सेल्सियस मेंटेन करने का तो करने का, irrespective of any certain condition, the HU will not be adapt to the condition. Just because of this current condition, there is a cost of energy increases in the usage. That will again increase the cost of optimization. And again, if the energy is huge, that will hamper the sustainability and again the net zero, which is most commonly going phenomenon nowadays. Third one is inefficient air quality management. So most of the HVAC, the conventional HVAC rather I would say, they are just trained and programmed to maintain the temperature and the relative humidity. So there is no provision of air quality monitoring or the data acquisition system for that. Fourth one is reactive maintenance. Once the system is been breakdown, then the system will be taken care of and repaired after thereafter. So that will again increasing the cost. The life of the HVAC system is again hampering, and the maintenance cost again is very much higher. The lack of data driven insights. So there is not provision of the historical data storage. Hence, the system cannot predict the future problems ahead. Second last, the occupant comfort challenges. As the system is just trained to maintain the 24 degrees Celsius, irrespective of any condition, will see or experience the hot spots and the cold spots to the entire building or the corner of the building, which is not desirable. And last, the limited integration with the other building systems. So there is a limitation with the integration of the other utilities like lighting controls, fire and security, access control, just because the entire data we have to store in one place, which will dedicated to the particular memory space. And in the conventional and the traditional HVAC system, there is a limited storage space. Hence, the synergy of the building is hampered, and again, the data of maintaining is very huge. Now let's see the optimization and the IoT in the HVAC. So the first slide will give you the insights of dynamic airflow balancing. Now, what does it mean? Dynamic airflow balancing. Yes, airflow balancing you may already know, but what does it mean dynamic? So dynamic airflow balancing is the variable airflow balancing which will balance the entire zone or the temperature or the relative humidity based on the surrounding condition, whether it is footfall increases or decreases, the relative humidity increases or decreases, or the most important phenomenon, the outside air temperature because of the sun gain. If you can consider and if you can see the rooftop unit, it is placed towards the east side. We are considering the placement of rooftop unit towards the east side, and when the sun rises from the east side to the west side, the damper condition will modulate basis on the real time data. Now see this animation. The sun is rising from east side. These dampers are modulating on the basis of sun gain, and the diffusers are opening on the basis of current condition. Because of this, we can maintain the entire temperature comfortably in the building and dynamically. That's the meaning of dynamic airflow balancing. Now we'll see the outside air optimization. Again, the outside air is very much crucial and results in the energy efficiency in the air handling units. Provides the optimal position of the outside air damper to regulate amount of outside air that is brought into the building. The first point is includes an economizer mode. What does economizer mode means? The economizer mode means it will reduce or minimize the mechanical cooling on the basis of outside air temperature. Now suppose if example the outside air temperature is lower than the ambient temperature, then at this time the mechanical cooling, the cooling wall of the cooling coil will be closed and the outside air will be drawn into the inside to maintain the comfort level. That way we can save the energy. The second one is demand control ventilation. If the indoor air is contaminated and the ppm level of the CO2 is very high, we'll see the uneasiness, dizziness. So this problem can solve by again drawing the outside air to the indoor spaces for maintaining the particular oxygen level. On the basis of that, the dampers, return air damper and the outside air damper will be modulating. The third one is competitive enthalpy economizer logic. Here, the outside air economizer, the outside air enthalpy and the return air enthalpy will be compared, and if the outside air enthalpy is lower, the outside air damper will modulate it on the basis of that and again optimize the indoor space. Now these are the little examples how we can use the IoT to optimize the energy and indoor air quality. Now we'll see quickly the benefits of IoT in HVAC. First one, the sensor deployment. The sensor deployment in IoT, there is a flexibility to install this sensor, many sensor in one sensor. Like one sensor you can install at one place to monitor temperature, humidity, CO2 levels, particulate matter, VOC levels, even the lux levels, and don't forget the occupancy levels. And again, the decibel, the sound decibels. You can measure number of parameters by the one sensors. The data collection and the transmission. The data collection will be on the cloud, and the transmission will again on the air. So there is no requirement of the wired, and totally wireless system will save your cost again. Third one is the remote monitoring. The monitoring, the building management system comprises the number of stakeholders like facility manager, building owners. They can monitor uh, the entire data from anywhere from the world, whether it is in-house or outside of the house or outside of the country as well. This is the most important advantage I have seen the IoT. Now, fourth is the data analytics and visualization. The power of analytics in the IoT is tremendous. It can compare the historical data and take the decisions to optimize the indoor spaces based on that. And visualization will give the total insights. Like one phenomenon I would like to phrase here, the digital twin. Nowadays, digital twin is rising tremendously. So, in digital twin, you can replicate the entire site scenario, whether it is the entire plant, chiller plant system, into the graphical representation, and each and every minute details in terms of the KW, the power consumption, each and every details. You can get the visualization in terms of digital twin. The alerts and the notification, you can raise the notification and the mails whenever the particular indoor air quality is hampering the particular threshold values. Then historical data storage, I have already spoken about it. And lastly, the integration with the other systems to find out the synergy between the building management system. This IoT enables the number of utilities on the one platform to monitor, control, and take the decisions, like lighting systems, and fire and security access control, and many other systems, generator systems. You can again integrate with that. That is the beauty of IoT I have seen. Now we'll see a quick case study. This is the case study. We have implemented the total IoT solution in the one of the retail store in the Max in Nagpur. Here, these are the cassette units, and the orange circle is the zone sensor. There were 9 cassette units which were contributing to the unique common area and maintaining the indoor air temperature. But because of the degradation of the sensor, there is no decision and taking the power of shutting down the particular cassette units. Then we have observed that, and we have implemented zoning, and we have dedicatedly installed our hyperstat, and we have associated one temperature sensors to the entire 3 of the cassette units, and on the basis of that, the entire cassette units are modulating, maintaining the indoor air temperature. Even in the inception, when we were into the inspection of the site, the few of the cassette units were turning on and turning off. But after the maintaining temperature, very few cassette units were turning off. So this problem we have observed, and it is now being overcome by this IoT. Now we have giving them the tremendous amount of energy saving. Again, the scheduling is there at the particular timing, that at the 10 a.m. in the morning, the system will be adopt automatically. Before shutting down, the system will automatically turning off. So that is the case study I had to discuss with you all, guys. Now, I can totally summarize this entire presentation in a small recap. So, in the inception, I have already told you I relate this IoT to the technological leader. So, you can see this IoT is a leader, and the number of employees are dedicated to the particular output, or working for the project to get the particular output. Here, the IoT will take care of all the decisions. It will assign a particular task to the dedicated person. It will take the feedbacks on timely basis. It will take the care of rest of the employee in terms of scheduling. It will take entire whatever the system needs to get the final result. That's all from my side. Thank you so much.